An object that absorbs more infrared radiation than it emits will increase its temperature. Remember that objects will heat up when they absorb infrared waves and release heat by emitting infrared waves. The difference between this absorption and emission is what determines how the object's temperature changes. For example, let's consider these ice cubes. They will absorb a fair amount of infrared waves from their surroundings, but they will emit very few waves at the same time. So the ice is absorbing a lot of energy from these waves, but releasing very little of that energy. So overall, the ice will be heating up, causing its temperature to rise. But what if an object is emitting more infrared radiation than it absorbs? Well, an object that emits more infrared radiation than it absorbs will decrease its temperature. Now let's look at this hot bowl of soup. It will also absorb a fair amount of radiation from the surroundings, but it will release loads of radiation at the same time. So it's releasing a lot more energy than it's absorbing, meaning that overall it will cool down, causing its temperature to drop. Now, what would happen if an object emits just as much radiation as it absorbs? An object that absorbs just as much radiation as it emits will stay at a constant temperature. Let's look at this orange. It also absorbs a fair amount of infrared waves, but will emit just as many at the same time. So it will be releasing just as much heat as it is gaining. This means that overall there will be no change in its temperature. However, in practice, the temperature could still change from things like conduction, work, chemical reactions, etc. So that's how temperature can change. But what is it that determines the amount of radiation emitted or absorbed? Well, the temperature of an object changes the amount of radiation it emits, but not the amount it absorbs. Let's compare the radiation we would absorb and emit when we're cold and when we're warm. In both cases, we would be absorbing radiation from the surroundings. Now, this will be the same whether we're hot or whether we're cold. The radiation we absorb is only determined by the conditions we're in, such as the temperature of a room, or if there are devices like heaters deliberately emitting infrared waves. Our own temperature will change how much radiation we emit, though. When we're cold, we won't emit many infrared waves, but when we're hot, we'll emit a lot of infrared waves. The greater an object's temperature, the more infrared waves it will emit. The fact that cold objects emit less waves means that they lose less heat, making it easier for them to increase their temperature to match their surroundings. Now let's look at what happens when we bring a warm and a cold object close together. The radiation transferred between two objects helps bring them closer to the same temperature. Let's now suppose we stand near a warm radiator when we're cold. Remember that despite the differences in temperature, all objects absorb the same amount of radiation from the surroundings. However, since the radiator is warm, it will release a lot of infrared waves, while we release very few since we're cold. Both us and the radiator will be releasing radiation in all directions, including towards each other. Notice that we would receive more radiation from the radiator than we give back. In other words, the radiator gives more heat than we would give it. This imbalance in how much heat we transfer means that we would heat up, while the radiator would cool down. This would continue until we are the same temperature as the radiator and we're emitting the same amount of radiation. For your exam, you should be comfortable explaining the links between the temperature of an object and how it is emitting and absorbing radiation.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!